In case people ask, but why call it supplemental?
You get bonus question.
Okay, so this is the way to express what you were mentioning. Okay, so you basically say for all xy in. Are we dealing with the function? Yes, we are. So for all xy in f, we will claim the following, and the following basically says. Something or something, because we have to separate into non-negative and negative side. So this is going to handle the non-negative side. So the non-negative side is basically saying if x is greater than or equal to 0, so that's a GE 0, right arrow,
Implies a y.
implies y equals 2x. Okay, now the other side is basically saying or x is less than 0. Right? I'm just matching the parentheses. Right arrow y equals minus 2x minus 1.
Would you need braces around the function? Because it's an element of, or
No, no,
so
it's
like
fine. F is a set, so it's okay to have it all by itself. So that basically finishes the whole thing, because basically I'm saying for each mapping in function f, depending on what x is and and also what y is, if x, which is the first of the tuple, if it is greater than or equal to 0, y is 2x. Or if x is less than 0, then y is minus 2x minus 1.
F as a set is either the first set or the second set?
No, f is one single set.
Okay.
But the elements, for each element in the set, I break it up into two cases.
Gotcha.
So basically, this is the first case, and this is the second case.
Conditions.
It's all about conditions, yes, because there's an implication here. So basically, this statement is automatically true. Oh, this should not be an or, this should be an and too. It should be a wedge. Because if it's or, then if it is less than 0, then I'm done. I don't really care about what y is. So it has to be an and, because in order for the entire expression to be true, both sides of the conjunction has to be true, right? So this side is, if x is actually negative, then this side is true because of the implication. Because when the premise of an implication is false, the implication itself is true already automatically. So that takes care of this entire side being true. But because it's a conjunction, you also need the other side to be true. So in order for the other side to be true, because this is true when x is negative, that means this also has to be true.
So when you have an implication as a condition of a conjunction, if the first part of the implication is false, then the other part of the implication has to be true based on the definition of an implication.
In order for the entire implication to be true, yes.
So it can either both sides of the implication can evaluate to be true, or the basis of the implication can evaluate to be false. And
Correct.
the other side is true. Okay.
Right.
So mathematically speaking, this is like a system of two equations, right?
This is a
System of two equations.
This is basically just describing what function f is.
So same as I'm like having calculus now.
It's not a system.
You have this. You have this one for this values. If you have these values, then you use this function.
Mm-hmm.
So it's the same thing.
Exactly, it is the same thing. Except in this case, I just use the quantifier and use implication to chop the function into different cases. So you can basically say, this is one case. This is how we chop off, the domain into different sections. So if it fits this description, this has to be true. If it fits this description, this has to be true. But this is how we basically, we can define the function that we talked about earlier in class to map all integers into natural numbers using a bijective function. And this describes one of those functions that can accomplish that without using a single word in English.
See, guys, that's nice.
That's the objective. We want to eliminate the use of English when we describe something like that. Because this is really concise and there are no two ways to interpret it. There's no way to misinterpret something like that. So that's kind of why we have to deal with all the symbols. So Chris was actually right. We really should be striving to use this kind of notation instead of using the more kind of, I was about to say wishy-washy, but the softer way, to use partly English and partly mathematical notation. This is all mathematical notation. It takes a while to get used to it, to kind of know how to read it. But once you know how to read it, it's very concise and very to the point. It can be wrong, but if it is wrong, you cannot. You can pinpoint which part of it is wrong.
In my country, the
Mm-hmm.
belongs to.
Sorry?
The the.
In
Yeah.
element of.
Yeah, in my country, we call it belongs to.
You can call belong to, or an element of.
Yeah, that's how I remember it. Belongs to that.
Right. Yeah. In is basically. It's used a lot too, the in word, because in some scripting language you can say, for each blah 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 in a whole set or linked list, do the following. Python does it use the word in between? Okay, so that's why most people remember this as in, but you can also say element of. Okay, that means the same thing, or belongs to. Yep. But I learned this a long time ago, so this is not like the first class where I use this. I have used LaTeX for a long time, but to use it within Moodle is kind of like the first semester. But I have used it for other things before this.
Well, when you talk about encryption, did you hear like the GPG author and maintainer? Like, there's only one developer, but like he's like going rogue.
GPG?
Yeah, the author for the GPG. Like,
Oh boy.
Yeah, like that's not a good sign. I think he tried to do a fundraiser around like to try to get some more money, but like.
Oh,
I
it's
think-
not.
Yeah, I think it's not voting well.
Oh,
Still recording?
this is still being recorded.
Oh,
You want to
yeah.
turn it up?
Oh, yeah.
Well, that part